Now we move to the next section, probability for management decision. And here now we are going to apply this probability into our business scenarios. And let us introduce a new concept called conditional probability. Conditional, right? Earlier we talked about mutually exclusive and right independent things. Now it's a condition, a probability that, for example, the event A, right? Event A is the condition of, right? It's a condition of or subject to event B, right? Event B. So that is called conditional probability. Right? So what is the probability of A, the event B, right? Event B happened. So event B is first be done. From that, we calculate probability of A, right? A conditional probability involves the computation of probability of an event A, computation of probability of event A occurring under condition that an event B has occurred. Right? Read again. Conditional probability involves a computation of probability of event A. Now we are going to compute probability of A. Probability of event A occurring under the condition, right? Condition that an event B occurred. So we calculate probability of A after event B occurred. So B is the past. B is the past, and we expect B later. This denoted as A condition B, right? We read like this. So this is the notation. Probability A subject to B, condition B. Probability of A under the condition of B, which read as the probability of A given B. So this is how we read this syntax. Like A union B, A intersection B. This is another thing, that is condition. Probability of A given B. So we have to take the sample space of B. From that, we have to find the common area to A. For example, the definition, first let us look at the definition. If A and B are two events, if A and B are two events on a sample space E, right? Sample space E, then conditional probability of A, it means calculating probability of A given that B has occurred. B has occurred is given by here probability. First we have to find probability of A, right? How we read probability of A given B subject to B. How we calculate the probability? First we have to take the intersection, right? The common area intersection and probability of B. So this is the preceding event. This is following event. Note that probability B should never equal to 0. Now we change the B and A like this. Probability of B given A. Here A should occur first, and then we have to find probability of B. Here probability of B, so B intersection A, common area, and probability of A. So this here A is denominator, B intersection A is a numerator. Here probability B is never equal to 0. Right here, this is the thing. Probability is not statistic, not static. Probability is not static. Static means not always it's not probability is not static, it's a dynamic. It's a only the change probability, so it's a change. It evolves. Evolves as we acquire new intelligence. So whenever we get new information, whenever we get new information, our prediction accuracy may be improved or be improved. The probability of A given B. Remember, B is the large, right? Is a large one. Is a denominator. This B, even B, should happen early first and followed by A. This is the formula, rule of thumb, general formula. Probability of A intersection B. It's mean common area, right? This area, common area, and it should be divided by probability of B, right? So this is probability of B, this area. So updated version. So this is the common area. This is the new universe. This is the new universe. Out of this, here we are not consider this. We are not consider this area. Universe. All we have to take, not net value. We have to take all B. So including intersection. And then we find. So if we take this is one X. If it is X, and if it is Y, simply X over Y. This is probability X condition Y. Clear? Okay, now let us try to understand using an example. Two dice are thrown together, right? Two dice thrown together at the same time. Final probability of getting 6, right? Final probability of getting 6 in one die, given that the sum of scores on two dice, right? The dice throw 2 times, no? 2 times. Then what are the outcomes we may get? 1, 1, 1, 2, 1, 3, and finally 6, 1, 6, 2, 6, 3, and 6, 6. Right? If you plot this, we can get there are 36 outcomes. Totally, when we throw 2 6-faced dice, it will give us 36 outcomes. You know, we have already discussed this in a graphical form. But the thing is, here we define 2 events. Final probability of getting 6, right? Anyhow, we have to get 6. Maybe in the first die or in the second die. A black die or white die, no matter. The order is not a matter. Anyhow, we have to get 6. That is event A, right? Let us define the event A and B. Event A means event of getting 6 in one die, right? Event of getting, and the condition in one die, given the sum of score of on the 2 dice is 7. For example, which condition may satisfy the 7? For example, 4, 3. So equal to 7. 5, 2, 7, right? And 6, 1. Another way around, first 3 and 4, and 2, 5, 1, 6. Their outcomes. These are the outcomes. Then here, how many so if we define these outcomes, sample space as B, even B, right? The even B, then we have to find probability of A given B. So condition B, right? We have to find the probability of A. We have for the sample space E, two dice are thrown together once. Number of elements in the sample space E. There are 36. Right? You know that one. A, right? What are the outcomes? A, right? We can get 1, 6, 2, 6, 3, 6, 4, 6, right? Or 6, 1, 6, 2, 6, 3, like that. So anyhow, at least we have to have 6. The value is 6. We have to 6. In the first, this area, right? This area we get 6, 6 at the first row. And this area, we get score 6 in the second row. Right? You can observe, right? The second value is 6. That is probability of A. And we define the event B, event of getting sum equal to 7. Here we get 7. 1 plus 6, 7. 2, 5, 2 plus 5, 7. 3, 4, 7. 4, 3, 7. 5, 6, 7. So this is probability at B. So these are the sample space of B. This is the sample space of A. Sample space of A. Then to find out the probability, we have to take this. Now we have to find, according to the formula, right? According to the formula, the common, right? The common. First we have to take the common area. So this is the common area. First we have to find common area. So this is common area here. This is, and here this is, so that we can take the common area. And 6, no, 6, 1. Right? So that we identified the common area intersect, and we know the outcome, right? Number of probability B. How many elements here? How many elements? 1, 2, 3, 4, 5, 6. There are 6 elements, and common elements 1, 2. Then probability is 1, 3. Oh, here, yes. Now you see probability of A intersection B, right? How to calculate probability intersection B? Number of elements altogether 36. No, altogether we know there are 30. This is another method, right? This is another method. Sample number, right? Number of element in the sample space. We know that 36. Now the first we are not considering condition. First we find, according to the formula, actually what I did here is a shortcut. This is shortcut, and this is the proper way. This is the proper way. Then we have to find number of elements in intersection. It's 2, no? 2. So here the formula, probability of A intersection B. Then we know that 36, 2 over 36. This is 1 over 8. And probability B, the number of elements in the sample space 36, and number of elements in event B, that is 6. So therefore 1/6. 1/6. And finally, probability of A given B is equal, is the formula, no? Probability, right? Probability of A intersection B. This is, right, this area, that is 1 over 8, 1 over 18. And probability of B, this area, right? And here, when we simplify this, we can get 1 over 3. Or we can consider the portion of the sample space corresponding to sum 7. This is a set outcome given by B. This set can be called reduced sample space for this problem. So two of these outcome have 6, the required probability is 6. This is a shortcut. That's what I did, right? But the thing is, the condition is it should be equally the probability of getting each event, each outcome should have equal chances. So then only we can use this formula. But the proper way of calculating probability in this kind of scenarios is this. Either you can use here, the preferred formula is probability of A subject to B, given B equal probability of A intersection B over probability of B. Or we can take number, right? Number A intersection B and number of elements in the event B. So both are correct. Clear? Any doubt? Any questions? Any questions here? So this is visualized here. Find the probability of rolling 6. Right? We are getting 6. Given the sum, dice equals 7. Dice is 7. The total sum, right? Sum of dice is 7. So these are the outcome. How many outcome? There are 36 outcome. Here there are 36 outcomes out of 6. We can get 6 here and 6 here. Right? Sample space. How many? The total, right? Total of 7. Sum of 7. 6, 1, 7, 5, 2, 7, 4, 3, 7, and 4, 3, 7, 5, 2, 7, 6, 1, 7. There are how many? 1, 2, 3, 4, 5, 6. This is B. And exactly 6, the rounded one. 6, 1 comma 6, right? 1 comma 6 or 6 comma 1. That is 2. Only 1, 2 our number 2. Then probability 1 over 3. Is it clear?
Yes, sir.
Okay. Now we move to the another example, business example, application of conditional probability. If in a factory, two similar machines, A, machine B, there are two machines, A and B, are used to produce item. For example, the company producing bulbs, right? The same product, but using two machine A and machine B, but output is one similar output. Produce items. Machine A produce 60% of the items, right? So if all total items are 100, A produce 60% of the output, and B produces 40% of the output. Machine A produces 60% of the item, and machine B produces 40% of the items. It is found that 5% of the items produced by machine A, right? 5% of the item produced by machine A are defective, right? Defective. This is defective, 5% defective. And this is good condition. Out of 60%, right? 95% of the outputs are good condition. And 3% of the item produced by machine B are defective, right? Here, 3% defective and 97% in good condition. An item selected at random from the production is found to be defective, right? Read carefully. An item selected at random. Here, all defective items, right? So this is the total production, no? This is total production. So we assume this is defect A, good condition A. This is defective item B, produced by machine B, and good condition produced by B. Then total output equal defective item A plus defective item B plus defective item, good item A plus good condition B. So this is total output. Here total defective equal defective A plus defective B, right? Total defective A and B. Assume that the machine produce, right, total 100 products, total 100 items, then total output equal what? 100. This is 100 units. And how much total defective? So machine A produce 60 now. 60, 5 item defective. Here defective 5 item. And machine produces 40 item, defective 3 item. Altogether 7 defective, right? 7 defective. The probability, right? The probability of getting, right?
Sir.
Sorry. Wait. Anything?
8, sir.
Which one 8?
5
sorry.
plus 2.
Okay, sorry. Thank you. 8 items defective. Now tell me what is the probability of what is the probability of getting defective item, regardless A or B, regardless A or B. The defective item we can get from A or B among the total production. What's the probability? Total item, how many? Total items produced 100, and total defective item 8. Then what's the probability of getting defective item? What is the probability? .08, isn't it? This is what probability of getting defective item among the total item produced. It's mean probability of defective item produced by machine A or B, right? This 8% represent what? 8% represent defective item, probability of getting defective item. Is it clear? Is this point clear?
Yes, sir.
Yeah. Now the question is, find the probability that this item was produced by A. Right? Now, right, an item is selected random from the production is found to be defective. Right? Find the probability that the item was produced by machine A and machine B. So what is that? What's the probability of getting machine? What's probability of getting defective that is chosen from machine A, that is produced by machine A. Second, the probability of getting defective item, that item belongs to machine B. The second question. So let we solve this. Let denotes the event that an item is produced by machine A, and B denotes the event that an item is produced by machine B. Let D denotes the event of getting defective item, and N denote the event of getting non-defective item. Here we use G. The probability, right? Probability is 0.6%. This is 0.4%. And here this is 0.05, and this is here 0.03. Right? The thing here is given clearly. Probability of getting A, right? 60, machine A, production machine A, production machine B. Here, let clearly look at this. Probability of defective item. Probability of defective item. The condition of A. First, we have to take the output, right? First, we have to take the output of machine A. Among that, we take the defective item. That chance is 5. We have placed here. And probability of defective item, that item produced by B. So first we have to take products produced by machine B. Among them, right? Among them, we have to find a defective item. Probability of that is 3. So we have find this way, right? Find that. Here, it's written very clearly, right? Here we start machine A, right? Machine A probability of producing the product. Machine A 60%, product B produced by 40%, and defective item, right? 0.05 defective item, and 95% of the items are non-defective. So, what's the probability of getting? What is the probability of getting defective item from A, machine A? So this is what? Sequence. This is sequence 0.6 into 0.05. That is what? 0.03, right? And machine B and non-defective items, right? Defective item, the probability is 0.03. Then we multiply these two, and here we get 0.012. Now see the total defective rate 0.03 and 0.012 altogether. So the defective item A, O, B. The probability of defective item A or B is maybe total altogether 4.2%. 4.2%. Right? Now we calculate the root cause analysis. A defective item was found. What's the probability? It's come from machine A. Right? Here, the total product item, right? First we have here in this case, we find total defective items, right? We are not considering the total item produced by the machines. No. Here, our sample space, total defective items, right? Here, for example, there are two baskets. This is basket is normal or good condition. This is defective item, right? Here, all normal goods in good condition produced by machine A and B put together, put on this basket, and all defective items are put in this basket. Also, defective A and defective B. Here, the question, what's the probability of getting an item from here, right? Probability of choosing an item from this basket that comes from machine A. That's the first question. Now our sample space is this, right? Sample space, of which we have to get the common item is what is specifically that should be defective and defective, and it should be defective and defective, and that should be produced by machine A. We have to find the probability, right? Probability thing is, and that should come from all defective items. All defective items. Here, total defective items. Here, we know the probability of total defective item is 0.42. Here, 0.42, of which, and the condition, right? The condition here, condition, the item is produced by the machine A. The total probability of getting defective item that is produced by machine A, 0.03. Then it's equal what? It's equal 71%. Likewise, machine B, this is constant, no change. But here, probability of getting defective items that's produced by machine B, that is 0.12. Then approximately 29%. This is one method, and we can apply this method here. Altogether 8%. So right now, tell me the total output produced by this machine defective. How many? How many? Based on this example, this scenario, tell me if the machine produces 100 units, how many items produced by machine A? How many items produced by A? How many units? Total production 100. A produces 60%. B produces 40%. Tell me how many units produced by A?
60.
60. B, 40. Out of 60, right? Out of 60, 5%, right? 5%. 5% is what? 5%
Defective.
defectives. I mean, what is the number? I think it's wrong. Yeah, I did. What's wrong here? Here, 60 into 5%. How many items?
3.
3 units. 3. Here, 3. Defective item is 3. And here, this machine produces 40 units, out of which 3 units. 3 units are defective. 3% are defective. 3% are defective. Then tell me, what's the number of outputs here? 1.2. Is it right? Is it correct? Correct or wrong?
Correct.
Yes. Then tell me the total defective item. Total defective items from A and B.
4.2.
4.2. 4.2. Out of which total output of defective item 4.2. Tell me the chance of getting that defective item produced by machine A. We have to put 3. Correct? Is it correct? Right. Likewise, probability of getting defective item that is produced by machine B. Total defective items 4.2 items, and the defective items 1.2. Then what's the probability here? Quickly calculate and tell me. What is the probability? 3 over 4.2.
0.71.
0.71. This means 71%. Here, what is the answer? Here, 1.2 over 4.2.
0.28.
0.28. So 28%. 2.28% and 71%. Do we get the same answer here? Here 71% and almost 29%, 28. 2 over 7. Right? This is a logical thinking. Right? This is, so if we don't know the probability theory, this is logical thinking. This is application of probability. Right? So what do you want? What the thing is, you have to clearly understand what does it mean here. Probability of defective item of A, right? Machine A. Sorry, probability of the item A. Probability of item produced by machine A subject to defective. So this is the thing. So you see this one, this basket altogether 100%. It is divided by here. Normal items are put. This item include produced by machine A and machine B. Here all defective items machine A and machine B. Here there are certain items out of this item and randomly choose one item, one defective item. That item belongs to machine A. Here the sample space is all defective items. For that, according to the formula, first we have to find out the probability of D, probability of defective item, right? And now we have to find out probability of A subject to D. Then probability A intersection D. So how to calculate A intersection D and how to calculate probability of D, right? So it is given. It is given here. It is given here. 0.03 is given, and probability here may be found. Sorry, 0.42. 0.042. So to get you get the same answer. Clear? Is it clear? Any doubt?
Yes, sir.
Yes, you may have doubt, right? You may have doubt. Others, if anybody else, anything, any problem? Anything else? Anything else? If you want, I can tell. If you have any doubt, I can reply, explain you. Any questions? I have already shared this material with you. Am I right?
Yes, sir.
Right, please go through this and do by yourself without looking at the answers. And if you have no doubt, you can see the recording. I will share the recordings, and you can clarify it. Or you can call me. I can answer. Okay. Now we will stop this session, and we will continue by tomorrow session.